the pH scale that I've drawn on the board for you runs from 0 to 14. Okay, with 7 straight up in the middle being what we call neutral. These are things that you may remember the old commercial, the Herbal Essence shampoo was pH balanced, you know, which meant it would not rob your hair of its natural oils. It would leave it like it found it, clean it, but leave it very soft and supple. That's what neutral cleaners are designed to do. Neutral products are designed to do. They're not real aggressive cleaners. They're designed to clean the surface, but not have any harmful effect after it. Now, what we find is that people will claim neutrality with regard to pH anywhere in a range from 6 to 8. I've even seen people claim neutral on a product that had a pH of 9. So it's there's kind of some flexibility with regards to the pH scale. Now you may be sitting there going, okay, 7 to 8, that doesn't sound like much. 7 to 14, that really doesn't sound like a lot. But for this scale to begin to make sense to you, you have to understand that it's an exponential scale. Okay? So when you go from 7 to 8 on the pH scale, the way to look at that is 8 is what we call 10 to the 1, or 10 times more alkaline than is 7. Okay? Anything on this end is alkaline up to 14. Anything on the low end, down less than 1, are what we call acids. So as you work away from 7 towards 8, 8 is 10 to the 1, or 10 times stronger than 7, or more alkaline than 7. 9 would be 10 to the 2, more alkaline than 7. Now 10 to the 2 is what?
10 times 10.
100. So now 9, even though 9 doesn't sound like much, 9 is 100 times more alkaline than is 7. Well, that's a pretty big number. Alright? 10 is 10 to the 3. Okay? So now we're at what? 1,000. So 10 is 1,000 times more alkaline than is 7. So now that's a big number. And when you get out to 14 and you start talking about 10 to the 4, 10 to the 5, 10 to the 6, 10 to the 7, you're talking about, it's like 10 million. 10 million times. 10 million times more alkaline than is 7. Okay? So now, while it doesn't seem like a big thing, 7, 8, 9, 10, when you get out here and you start talking about 10 million, you're talking about products that are really alkaline. Okay? And it works the same the other way. In other words, 6 would be 10 to the 1 more acidic than is 7. 5 would be 10 to the 2, which would be 100 times more acidic than is 7. And when you get all the way down here less than 1, again, you're talking about something that is tens of millions more acidic than 7. Okay? So products that tend to be at either end of this pH scale tend to be things that you need to show some respect to. The things that we work with every day in our industry would be a wax stripper, would be something that would be up here above 13 on the pH scale. That's why we tell you to wear gloves, wear goggles, don't get in there with tennis shoes with holes in them, because you're working with a chemical that from a pH perspective is not going to do your skin any good. It's going to dry it out, it's going to make it peel off. So these aren't products that you need to get in. You don't need to get in stripper solution in your tennis shoes with holes in them. You need to wear foot protection, and you need to have your glasses and your goggles when you mix it, and have your gloves on. On the other end of the scale, a product that we might work with a good bit that's less than 1 would be, that's an acid, might be an acid bowl cleaner. These are products that if they get on your skin, they tend to burn you. They can discolor your clothes. You need to watch what surface you put them on. So products that are on either end of the pH scale are products that you need to show, you know, a little bit more respect to, and make sure you have on the protective equipment this prescribed on the MSDS sheet. Now, how do you plug this information in to where it makes sense for you? Well, let's talk about that for a little bit. I told you that when our lab built a product, the first thing they look at is what are we going to be trying to do with that product? You know, what's the soil we're going to be trying to clean? And here's how an understanding of this can work for you. If you look at a ring in a commode, what is a ring in a commode made out of? If you go to a commode and you see a ring in it, What is that ring actually?
Calcium.
Calcium, lime, hard water deposits. What do you think the pH of those hard water deposits tend to be? Any idea?
Very alkaline.
Very, very alkaline. Hard water is very alkaline. Okay? So if you have an alkaline deposit and you want to chemically clean it with chemical action so that you don't have to scrub so much, you've got something that's way up here on the pH scale that's very, very alkaline, an alkaline ring in a commode, and you want to clean it without physical action. You want to do it chemically. What do you think the pH of the cleaner needs to be? Good answer. You need to have an acid cleaner. And if you've ever done it, you know for yourself, if you take an acid cleaner and you put it on a mineral ring or an iron water ring, it will disappear in front of your eyes. It will chemically clean it and you don't have to scrub. That's choosing the right product for the task. Now NABC, which Glenn said earlier, is the #1 selling product in our line. You could take NABC, which is also a toilet bowl cleaner, and you could saturate that mineral ring with NABC. NABC is non-acid. It's got a neutral pH. So you could take NABC, which is neutral, you could put it on that same ring in the commode, and what effect would it have? You'd never move it chemically. Now if you had a pumice stick or a green pad or something, you might could move it. But you would never move it chemically because NABC doesn't have the pH required to chemically move the ring. Okay? Now think about something else we're doing all the time. What about if we're going to mop a floor? We've got 6 or 8 coats of finish on. It's a really pretty shiny floor. Okay? And we want to keep that shine, but we also need to clean the floor. What do you think the pH of floor finish is? Anybody got a guess? The floor finish pH most of the time is going to be somewhere in here between 8 and 9. Most floor finishes are going to be between 8 and 9 on the pH scale when they're dry. Okay? So if we're going to come in and we're going to mop these products, do we need to mop them with bleach that's up here at 13? Or pine oil? Or even multi-surface cleaner that's between 10 and 11? All-purpose cleaners. Is that really what we need to mop our high-gloss floors with? No. We need to mop them with a neutral cleaner. Okay? That won't attack the finish. Because the pH of the neutral cleaner and the pH of the finish are more consistent. So on floor care it has an impact. The last example I would give you of how you can use some pH goes back to kind of restroom or shower room. If you're dealing with soap scum, alkaline residue, again, on the side of a shower wall, soap scum, alkaline residue, hard water, lime in your water, again, in that situation with a shower, you'd want to go with a product that might have a foaming acid that would give you some dwell time on those walls and would also neutralize the rust, the scale, the body oil on the wall. So understanding what you're cleaning, whether it's floor care, carpet care, restrooms, surfaces, understanding what you're cleaning, the soil you're cleaning, and then selecting your chemical is, well, you'll get a lot better result by letting the product work chemically as opposed to you having to scrub. Okay? Alright, now what I wanted to do now is talk a little bit about, with this in mind, some of the products. I want to start with some of the products I think that we go through the Clean on the Go with. Okay, and some of the benefits of those products so that you'll know.
Well, Mark, before you get into that,
okay,
is it pretty safe to say that in cleaning, that if you're cleaning an alkali, you use an acid. If you're cleaning an acid, you use an alkali?
That's how you're going to neutralize those, you know, if that's what the object is. I mean, there might be times when you want to use, like on the floor finish example, you want to use a pH that's more consistent because you're not looking for a neutralization. You're not looking for an opposite. You're looking for something that's compatible. So I mean, the understanding of this is that if you want to clean something, but you want to have as little impact as possible on the surface itself or what's there, then you want to use something that's pH compatible with it. If you're trying to get a reaction,
Like restorative cleaning.
yeah, then you're looking for something that's got polar opposites. Does that make sense? But like in the case of trying to mop your high gloss floor finish, you don't want to, you don't want something that's at either end of the pH scale. You want something that's more compatible. But when you're trying to rip out a mineral ring from a commode, yeah, you want something that's on the opposite end, because you're trying to do that as efficiently as possible. And you've got an acid-resistant surface there in the vitreous china. You're not going to hurt it. So I guess the thing is the whole awareness of the whole purpose of being aware of this is just understanding that everything's got a pH. If it's water soluble, it's got a pH. Understanding the soil you're working with and the chemicals at your disposal, and making a good choice based on whatever it is you're doing. If you ever have any questions, you can always get a hold of me or our lab, the 800 number on the bottles, and they'll give you some good guidance there too, as far as which product to select.